Hello, everyone, and welcome to my channel. This is an educational channel, and we try to look at all-encompassing theories of everything, holistic theories, holistic viewpoints, paradigm shifters, um, other things, magnum opuses and tour de forces from obscure or esoteric works, ancient or modern, and just about anything else that you can think of that could benefit your life if you knew about it, but you probably don't because it's been suppressed. And today is our 403rd video on the reciprocal system of theory. And this is a theory, or a system of theory, which was originated by Dewey B. Larson back in the 20th century. In 1959, he proposed his two fundamental postulates, which was kind of a crystallization of all of his inductive work up to that point, and he boiled it down to a couple sentences about how he believed that the universe operated. Then he took those two fundamental postulates, and through a process of deduction, he derived a theoretical universe, a universe of how the universe would look if his postulates were correct. And then he compared his theoretical universe with the so-called actual universe of modern science, what they have measured in their laboratories and observatories, having to do with, basic properties of the elements, the compounds, the stars, the galaxies and planets, and subatomic particles and cosmic rays and anything else that you could catalog. Larson attempted to more or less recreate those tables, and he didn't attempt to recreate those tables. He attempted to propose a theoretical universe, but it so happened that he more or less recreated the tables. There are differences, there are discrepancies, but over 90% of it is, very well within experimental error, and most likely is a result of experimental error of the army of scholars and scientists who put these tables together, as opposed to Larson, which is just the theoretical. So Larson was able to basically reproduce a lot of what the scientists have been able to produce over the course of thousands of years. Probably tens of thousands or hundreds of thousands of scientists, and probably trillions of dollars. And Larson did that with his slide rule, and while still keeping a day job. So that kind of, to me, means that his system could be quite powerful and worth learning about. So that's what we're doing here. And today we are embarking on the fourth installment of a paper that he gave back in 1968 called Around Unexpected Corners. It's kind of an autobiographical paper, talks about the various things that were at stake, and the approaches of the scholars and scientists, and then how Larson fits in with that, how his reciprocal system of theory fits in with that. At the end of the last episode, we were talking about how, or he was talking about how modern science has basically degenerated into an imaginative subject where they're basically using their imaginations to speculate on, um, how things operate, and they've been forced into that position because they do not have a holistic theory about things, and so everything is a patchwork, and so nothing is tethered, nothing is tethered to anything else, and each one of these fields is just kind of drifting off into its own area. And we'll get into that. We'll go back about a paragraph and get into a little bit of that before we finish up the paper. But before I do that, let me just let you know about Larson's fundamental postulates so that you have a little bit of background. He has two fundamental postulates, and the first one is by far the more important. And the second one, in fact, has been disputed by some of his followers, several aspects of it. But the first postulate is where most of the content will be coming from, and that is that the universe is composed entirely of one component, motion, existing in 3 dimensions, in discrete units, and with 2 reciprocal aspects, space and time. Okay, so basically, the universe is not made out of matter. It's not made out of energy or anything else. It's made out of motion. In particular, it's something that Larson calls a scalar motion, which is kind of a more non-localized, more general, more universal kind of motion that is a motion that has a magnitude but has no specific direction. So this is a non-directional motion, which you can envision using a balloon with dots on it. If you blow up the balloon, all the dots are moving away from each other. If you suck in the balloon, all the dots are moving toward each other. But they're not moving in any specific direction, or they are moving in every direction. And that motion has kind of been ignored by the scholars out there. They haven't really figured out what to do with that, even though they recognize that it is a reality. They have relegated it to kind of a sideshow and have not really investigated any of its properties until Larson came around. And Larson has made scalar motion basically the centerpiece of his system of theory. So the universe is made entirely of motion, in particular this non-localized motion called the scalar motion. And motion is the relationship between space and time. That sets up a generalized reciprocal relationship between space and time. Motion is basically a fraction, with time or space as the numerator, and space or time as the denominator. If you don't remember your math, the numerator is the top of the fraction and the denominator is the bottom of the fraction. So space and time as reciprocals of one another are, by definition, the same, except that they are in different order. So basically, the reciprocal of 4 is 1/4. You have 1/4, 1 over 4, and you have 4 over 1. They have the same qualities, but they are in different order, or different numerator, different denominator. And if you multiply them together, you get 1. And like other reciprocals, space and time do not exist in and of themselves or separately. They only exist together in motion. All of our basic scientific entities are forms of motion, such as matter and energy and force, speed, acceleration, pressure, electric charge, electric current, magnetic flux, electrical capacitance, surface tension, viscosity and fluidity, power or luminosity. These are all different fractions with space or time as the numerator and time or space as the denominator. But time or space both can be multidimensional. It's what Larson refers to as coordinate space and coordinate time. We see space as being multidimensional in our environment, volume, or XYZ coordinates. And it's a still frame of XYZ coordinates. And since space and time are reciprocals, that also means that time has 3 dimensions as well. And maybe not XYZ coordinates, but possibly IJK coordinates, and in a still frame. That's what Larson calls coordinate time and coordinate space. Then there's clock time and clock space, and these are the scalar components. The clock is always getting later and later and later and later. It's not getting later in any specific direction. And then the clock is always getting farther and farther and farther apart in space. That's what Larson calls clock space. And farther and farther and farther apart, but in no specific direction. And then also space and time have, they come in only discrete units. You have to have they are quantized. You have to have a minimum unit before you have any, before you have that entity. So you need a full unit of space before you have space. And need a full unit of time before you have time. These are small units, but they do exist, and so they come in chunks. Space, a unit of space is 4.56 times 10 to the minus 8 meters. A unit of time is 1.52 times 10 to the minus 16 seconds. If you have 1 unit of space in 1 unit of time, you have what Larson refers to as unit speed, space over time being speed, and 1 unit of space in 1 unit of time being unit speed, which is also known as the speed of light. So the speed of light is 1 unit of space in 1 unit of time. And this is the background motion of the universe. Larson refers to it as the progression of the natural reference system, the null point, the neutral point, the 0 point, the ether, the origin. These are all different terms that you could use to describe this outward motion at the speed of light in all directions. That is something that is always present in this universe, omnipresent in this universe. When you have an empty universe, when you have nothing in your universe of motion, you still have the speed of light outward in all directions. So in order to kind of grasp the reciprocal system, you have to be able to understand that motion exists before anything moving. And you have to see that there is this speed of light outward in all directions at the speed of light. Always present. It's the neutral point. So that basically means that half of the universe is actually moving faster than the speed of light. Half is moving slower than the speed of light. Larson refers to these as the cosmic sector and the material sector, respectively. And that flies in the face of legacy scientists who claim that, like Einstein, that the speed of light is the maximum speed of the universe. For Larson, is the midpoint of the universe. They measure all of their phenomena from zero speed. Larson measures his phenomena from unit speed. Basically, the difference between an additive system and a multiplicative system. With an additive system, you start with the middle at 0, and in the positive direction, you go 1, 2, 3, 4, 5. In the negative direction, you go -1, -2, -3, -4, -5. With a reciprocal system and a multiplicative system, you have 1 at the center, not 0. And in the positive direction, you go 2, 3, 4, 5. But in the negative direction, you go 1/2, 1/3, 1/4, and 1/5. And so that makes a big difference between the two different systems. So we have this cosmic sector that the legacy scientists don't know anything about, but they can bridge the gap quickly because the cosmic sector is the reciprocal of the material sector. So if you know what's going on in the material sector, all you have to do is switch the functions of space and time, and you get what's going on in the cosmic sector. In the material sector, you have coordinate space, 3 dimensions of space in a still frame, and you have clock time. The clock is always getting later and later and later. In the cosmic sector, you have coordinate time, 3 dimensions of time in a still frame, and you have clock space. Space is always getting farther and farther and farther apart. So that shows you the reciprocal relation. Okay, now let's get to this paper. I'm going to go back to a quote that he has here. I believe, let's see. Okay, Lindsay. This traditional viewpoint and their present attitude is described by Lindsay in these words. We are, quote, we are essentially viewing the purpose of physics as a scientific discipline as invention rather than discovery. The term invention implies that the physicist uses not only his observations, but his imaginative powers to construct points of view that identify with experience. Einstein was very emphatic on this score and insisted over and over again that, quote, we can only grasp physical reality by speculative means. McVitie makes the same point in these words, quote, the laws of nature are to be regarded as free creations of the human mind. End quote. The inevitable result of giving free rein to the imagination in this matter has been that physical theory has lost touch with reality and has embarked on a course of pure speculation. Just in case you might feel that this picture that I am giving you is overdrawn, let me say that Werner Heisenberg, one of the principal architects of the modern speculative theory, is on record to exactly the same effect. He admits that modern science has, quote, lost the whole representation of reality, which has been the basis of the exact natural sciences up to the era of today's atomic physics. End quote. When our primitive ancestors were confronted with something which they could not understand, their answer was to invent what we may call a demon. a supernatural being or power drawn from their imagination and specifically adapted to the purpose at hand. When the present-day theorist is similarly confronted with something which he cannot understand, he does exactly the same thing. He, too, invents a demon, a hypothetical force or phenomenon, which is designed specifically for this purpose, which has no other function, and whose existence cannot be verified by any independent evidence. There is no essential difference between the rain god that brings a much-needed shower for the benefit of the crops of the primitive tiller of the soil, and the nuclear force that holds together the hypothetical nucleus of the atom, or that holds the hypothetical nucleus of the atom together for the benefit of modern theorists. The explanations sound different, of course, because each cultural and professional group has its own jargon. But the essential character of the explanations would remain unchanged if the primitive farmer propitiated the rain force and the physicist invoked the aid of the god of the nucleus. A demon is a demon, regardless of the particular linguistic clothes that he may happen to wear. It is the wholesale use of these demons and the consequent retreat from reality that is responsible for the unsatisfactory state in which so-called modern science now finds itself. And it should be no occasion for surprise when a new theory that does not utilize demons calls for some drastic changes in the most demon-infested areas. But it should be remembered that, in spite of the great amount of publicity that they receive, these highly speculative modern developments actually constitute only a relatively small part of physical theory in general. Even the textbooks, even the physics textbooks, rarely devote more than 10% of their contents to material of this nature. And the effect on other branches of science is very much less. The remainder of physical theory, perhaps as much as 95% of the total, has been constructed by the sound and reliable methods of traditional science rather than by free association or free inventions of the human mind. And my new theoretical system is generally in accord with this sound portion of existing theory. As I have stated in my books, almost all of the theoretical relations applicable to our immediate environment that are firmly enough established to enable using them on a practical basis, such relations as Newton's laws of motion, the gas laws, the laws of thermodynamics, the kinetic theory, and so on, can be derived from the postulates of the new system in essentially the same form in which they are now known. Even the changes which the new theoretical system does make in these more familiar areas are often more a matter of altering the terminology than of any substantive modifications. But there are many gaps in existing theory, and these gaps are so prominent in your own branch of science that chemistry is often characterized as primarily an empirical science. The leaders of your profession have long been hoping to remedy this situation by developing an adequate chemical theory. At one time, it was thought that the application of quantum mechanics to chemistry might be the answer, but the results of this effort have been disappointing. In fact, Professor Henry Bent of the University of Minnesota makes this flat statement in an article in the magazine Science. This 30 years of, quote, this 30 years of labor has produced not one firm prediction about even the simplest test tube experiment. You and your profession are thus in a very favorable position to get the maximum amount of benefit out of the new development that I have been describing to you. A development that will ultimately give you that comprehensive chemical theory that has so long been lacking. It is on this basis that I commend it to your thoughtful consideration. Okay, that is the end of that article, Around Unexpected Corners. And that was a talk that Dewey Larson gave in 1968. And that, I guess, is kind of fitting in that he's speaking to a room full of chemists. And I believe tomorrow we will embark upon our foray into chemistry. We're going to be featuring Dewey Larson's book called Basic Properties of Matter. And in this book, Mr. Larson shares his theoretical universe as far as chemistry is concerned with us, and compares his results with the scientific tables having to do with the periodic table. And, such qualities as the interatomic distance, the compressibility, things like melting point and boiling point. These are all things that he discusses in this book. Now, hopefully we will be able to navigate this book. It is a little bit technical at times, but I've read it several times, so hopefully I'll be able to kind of guide you through the various mazes that Larson might be taking us. He writes clearly, but sometimes he refers to things that a layperson might not know, and so we will try to make it comprehensible for everyone. Unfortunately, the whole book is not comprehensible to me, so I might not be able to help in certain areas, but I will do the best I can. And so tomorrow when we come back, we're going to be looking at Dewey B. Larson, The Basic Properties of Matter. It's a book that he wrote in 1987, and this is the second volume of his 3-volume work called The Structure of the Physical Universe. The first book is on mostly atomic physics. We went through the majority of that book. It's called Nothing But Motion. Then Basic Properties of Matter, and then his third book there is called The Universe of Motion, which is on astronomy. And so, come back tomorrow and we'll check out Basic Property, the beginning. It should take us quite a while to get through that book, but we will at least get started tomorrow with Basic Properties of Matter. Thanks for tuning in today, and have a wonderful day.